Hello friends, I am Prithviraj Singh and I warmly welcome to you my channel Physmatics. Today we will discuss about a very important chapter and it's a very long chapter, so we have divided it into some segments. This is the first part and this chapter's name is wave motion and sound. Okay, we will cover these topics in this session and all the topics are divided in other segments and sessions. So we will, by further now not wasting our time, we will start our session. First topic is vibratory motion. Vibratory motion is a motion in which any object moves to and fro direction. Okay, which means suppose there is a swing. Okay, there is a swing and the children is playing. This swing goes to and fro, firstly in this direction, secondly in this direction. Then this type of motion, if this type of motion is in a fast, then we can say that suppose molecules like this, but that this can be vibratory motion, and the slower motion of this type will be oscillatory motion. Now the second topic we will cover is mean and extreme positions. For this topic I have to make a diagram of a simple pendulum. Simple pendulum is like a string and a bob, and suppose this string is fixed at a point. Okay, suppose this string is fixed at the upper point and the bob is suspended from the string. Then if we tilt it some and give a force towards any direction, then it goes in both directions, firstly in one and secondly in another. Then we note that both directions distance traveled by the bob is same, which means if we push it to this position, then it will back again, it will reverse on its path and cover a distance equivalent or equidistant from this position, and the very position from which we started. So this is called mean position. Okay, when the bob is suspended as it is, then that position is called mean position, and the movement of the bob in either direction, then the highest position achieved by the bob is the extreme position. These two are extreme positions and this is mean position. Now we will talk about amplitude or discuss about amplitude. Then the displacement, horizontal displacement covered by, this is the horizontal displacement, the horizontal displacement covered by the bob in a given time from the mean position to the either of extreme position, which means only one extreme position, the given period of time which is taken by the bob to cover the horizontal displacement of from mean position to the extreme position, that displacement is called amplitude. Okay, this is amplitude and this is amplitude. As in physics there are two directions and denoted by positive and negative sign, so you can denote this by a plus and you can denote this by a minus because they are in different directions. Now we will discuss about time period. Now before some moments I have talked about time period. Now I will describe it. What is time period? This is a system of simple pendulum and the bob will move in either directions. Okay, then the time taken by the pendulum to cover a cycle. A cycle is called one whole oscillation. A oscillation consists of movement in both directions, which means suppose this position is A, this position is B and this position is C. Then the time period will be taken by the distance covered from A to B, then B to A, and then B to A to C, and then C to A. Okay, which means from the time taken when the bob is in the mean position, then the bob starts moving and touch its one extreme position and come again and touch its another extreme position and again come to rest as the mean position, on the mean position. Then this whole time taken is called time period of simple pendulum. Okay, then our next topic is frequency. As we have talked about, the time taken by the simple pendulum to cover one oscillation is called time period, and frequency is just a opposite term. Frequency is the number of oscillations covered in 1 second or each second. Okay, the number of oscillations covered in each second is called frequency. Now the other topic, simple pendulum. Simple pendulum is the structure like this. 1 minute, I will draw this more clearly so that you can understand it properly. This is a structure like this. This is a string, a bob, and the string is fixed to a fixed point. See this picture? Okay. The simple pendulum has 3 laws mainly. First law is the simple pendulum. Okay, the time period taken, the time period of the simple pendulum of a given length. Length is this, length of the string. Okay, L. L denotes to length. The time period of a simple pendulum, okay, of a simple pendulum for a given length is independent of amplitude, which means if we take a bob which amplitude is here, okay, and we take a bob of similar length L and its amplitude is smaller, okay, then the time taken will be not same. The time taken will be deferred, or the time period will be deferred. First law we have discussed, and we will now discuss the second law of simple pendulum. Second law of simple pendulum says a similar thing like that. That is the time period of a simple pendulum for a given length, which means the two pendulums will be of same length. The time period of the simple pendulum for a given length is independent of its size, shape, density, and mass of the bob. Bob is this mass, okay? Then suppose there are two amplitudes similar to this, okay? Suppose these two amplitudes are similar. Then the time period of this simple pendulum will not dependent upon the size, shape, density, and mass of this bob. We have discussed two laws, and the last law and the third law is that, then our question is that, then what is time period dependent? We will now discuss it in the third law. Time period of a simple pendulum is directly proportional to the square root of its length, which means there will be two pendulums or more, and their length of the string or their length will differ. Their length will not be similar. Okay, their length is, suppose this is small l and this is large l, and they both differ in measures. And then both time period which is denoted by t will be directly proportional to square root of length. Okay, time period is directly proportional to the square root of length. I hope that you guys understand it well, and I will meet you in the next session with the part 2 of wave motion and sound. If you have any problem, you can ask in the comment box. You are free to ask, and it will be my pleasure to answer those questions. So guys, meet you in the next video. Bye.